Hello, in this video we're going to begin to wrap up the project. At this point we're going to assume that we've done all the calculations for our client's 401k, Roth, and normal stock account. And so we know how much money each of those grows to. And now we're at the situation where our client comes to us and said that they've won a small little lottery prize in maybe a scratch-off ticket. And after they paid taxes on it, they received about $1,475. And rather than just blow that, they really want to use that to help fund their retirement. So they invest it as a lump sum into a new Vanguard account. So this is a fourth account. And maybe they buy some mutual funds with it. And so they have this new fourth account, and we just want to quickly calculate what's in that account at the time of retirement. So because this is a lump sum, we can use the basic compound interest formula, which tells us that the total amount, capital A, in the account will be equal to the starting amount multiplied by this quantity raised to this power. The rate of return R, of course, is 0.072. That's the rate that they earn during their working years. There are 12 compoundings per year. And the amount of time in years, 40, is how much time our client has before they retire. So these numbers are all going to be different for your project, but for our class project, that's what they turn out to be. And what we see is that this $1,400, roughly, grows to more than $26,000 after 40 years. So that's going to go into the pot, so to speak, for all the resources that are available for our client to use at the time of retirement. So let's take a look at that real quick. Again, our client is 27, will work for 40 years, retire at 67. They want their money to last for 23 years to the age of 90, and they're assuming these as their rates of return: 7.2% during working years, W, and 5.2% during retirement years, capital R. So their 401k account started with $7,000. They're going to put $200 per month into that, and both of those things are going to grow to a total of $679,000. Now keep in mind, this is a lump sum and this is an annuity. So the way that we calculate this total is from applying two formulas. One is the basic compound interest formula for a lump sum, and the second one is the annuity formula. We do the same thing for the Roth account. It starts at $2,300. Our client puts in $115 per month, and all of that grows to about $360,000. Our stock account, the normal one before any lottery winnings were announced, started at $2,900. Our client puts in $200 per month for 40 years, and that grows to a little over $600,000. So you can see you get large amounts of money through regular investing if you have a long amount of time for those investments to grow. The lottery winnings were only $1,475, and we just discovered that that grows to about $26,000. So notice something, that this amount, this $26,000, is much lower than the rest of these. And of course, what that tells us is that this regular deposit of money into the other three accounts on a monthly basis really does drive up the totals in these investment accounts over time. And of course, there's a lesson there for you as you start thinking about your own retirement. In any case, when we take these totals and add them up, it gives us about $1.67 million. Sounds like a lot, but of course, we haven't adjusted that for inflation yet. So these are future dollars. Keep that in mind. The question is, how much monthly income will that generate? Not only in future dollars at the time of retirement, but also in today's dollars. So we're going to work through that here in the next few slides. This is one way to display this information. For your report, it might be easier and much clearer for the reader to put these totals into a table of some sort. Visually, this is much easier for someone to read and to decipher than trying to put it all into words into a paragraph with all the numbers mixed in with the words. So I would encourage you to create a table like this one to use for your final report. So now we're going to begin to think about how much monthly income will our client get before we adjust any of that for inflation. So we're going to recalculate this because initially what we did was we figured out how much monthly income our client would get before the lottery winnings. And so we had some total. We've already done this before, but now we have to recalculate it because we have a new total retirement account value due to the lottery winnings. So the formula that we're going to use places W, the withdrawal, the regular withdrawal that we can expect to receive, on one side of the equation isolated by itself. Capital P is the amount of money in the account. Little r is how much interest we can earn during retirement. So this is important. These withdrawals are taking place during retirement, not during the working years. So any money that we don't take out during the retirement years doesn't earn 7.2%, the higher rate anymore. It earns the lower rate of 5.2%. So little r is the interest rate during retirement. K is still 12, and T is now a new number. It's not the total number of working years, which was 40. It's the number of years in retirement. This is the case because we want these withdrawals to last not for 40 years, but for 23 years. And they're only earning this lower rate of interest for 23 years. So we've got to make sure that we get these numbers correct. Otherwise, we're going to end up with numbers that are not accurate. When I throw this into a calculator, I end up with $10,395.59. Now, that sounds like a lot of money, but remember, our client is 27 and is going to retire at age 67. So this is money that they're receiving 40 years from now, and these are future dollars. So the big question is, what is the spending power of this amount of money, this $10,400 roughly, in today's dollars? If we will not be able to purchase in 40 years the equivalent of $10,400 in today's goods because everything's getting more expensive due to inflation. So we have to figure out how to adjust this, right? So our client is asking us to assume that the rate of inflation is 2.2% annual inflation rate. So if we use the inflation formula, and here's one version of it, and we rearrange it so that capital A is the amount in the future, these are future dollars, and little a is the amount in today's dollars. When we plug in the future dollars of about 10,400 and we put in the inflation rate of 0.022 and we put in a time of 40 years, we get out $4,353.25. Now you may be wondering, why are we using 40 instead of 23? Well, the answer is simple. Our client is 27 years old right now and is going to retire in 40 years at age 67. So 40 years from now, our client is going to receive a check for about $10,400. And so we have to take into account inflation working on that amount for 40 years during their working life, not during retirement. So we've got to make sure the time is correct here. And this is our adjusted monthly income after we adjust for inflation. So $10,400 in the future can only buy the equivalent of about $4,353 in today's dollars. So it's more than cut our spending power in half. Keep in mind, this is still short of the client's $5,400 goal that was given to us early. So each team, each individual project specifies their client's monthly income goal during retirement, and our client has told us they want to have $5,400 in future money at the time of retirement. And you can see right now they only have about $4,353. So they're short. One way to figure out how to address that shortage is to adjust that $5,400 upwards for inflation. So remember, this $5,400 is what the client reports to you about what they want to be able to spend in retirement. But they're talking in terms of what they can spend now with $5,400. So what we have to do is we have to figure out in 40 years, how much money will our client need to have in monthly income to have the equivalent spending power of $5,400 today? So again, we have another inflation adjustment calculation where we look at the amount, capital A, in the future for a present today's dollar amount of $5,400 after it grows by 2.2% for 40 years. And what we see here is that in reality, our client is going to need 40 years from now a monthly income of about $12,900 to have the same spending power as they do today with $5,400. So this is the monthly amount of money that we want coming out of our clients' retirement funds. Not the $10,400 that we're getting now. We actually want about $12,900. So what we got to do is we got to figure out how to make up the difference between this $12,900 here and this $10,400 that we're currently expected to earn based on the investments that they have right now. So what we're going to do here is figure out how do we generate that $12,895.24 per month. So the idea here is to say, if we know we're going to withdraw W, this $12,895, and we're going to do it for T years, and we're going to earn a rate of return during those withdrawals of the remaining money, then what is the principal P at the start of the withdrawals that needs to be there in order to generate this monthly withdrawal of $12,895? So when I plug that W value into the equation, and then I plug in the rate of return during retirement, the number of years, 23 during retirement, and the number of monthly payments, or the number of payments per year, which is 12, and we do this calculation, we get $2,073,602 and about 87 cents. Now again, remember, we've got to be careful with what numbers we use here. We're talking about withdrawals during retirement, and the remaining money is earning interest at a lower rate, right? So during retirement, we're taking out 23 years worth of payments, and we're only earning 5.2%. So that's why we're using these numbers in this equation, because with those withdrawals are being taken out over a 23-year time span, not a 40-year time span. Our final result tells us we need a little over $2 million, about $2.1 million roughly. Okay, and so that's what our client is actually going to need in their retirement fund. And so we can compare that to what we think they're going to have now. So let's see how short our client is. We need 2.073 million. We discovered earlier that they're going to have a projected total of about $1.671 million. And so that means they're about $400,000 short, which sounds like a lot of money. But again, remember, we have two things on our side. Number one, time. We have 40 years to make up this amount of money. And we saw earlier that if we're putting in monthly contributions on a regular basis, those things over long periods of time can grow very fast. So this $401,000 is what we need to make up. That's what we're short. So what additional monthly investments do we need to add to our current 401k and Roth IRA and stock account contributions in order to make up this shortage. Now we're going to use the formula that tells us the relationship between the amount of money that's going to be in an account if we make regular deposits of little d. And so we have everything we need except for little d. We need to know what monthly deposit is going to generate $401,000 in 40 years. Again, why 40? Well, that's because our client is age 27. We know they're going to be short. They're going to be short in 40 years, and so we are going to advise them to make new, regular, additional monthly contributions of little d dollars. And so when we throw our numbers into this calculation, it tells me that a monthly deposit of $144.75 will get us, in 40 years, to a little over $400,000. So that's not bad, right? I mean, this $400,000 sounds like a lot of money, but with time on our side and a decent rate of return and discipline in putting in those monthly contributions, we're only going to need about $145 per month to reach our goal.